almost evening, so good evening to everybody who's made it here. So Raghav and myself are colleagues. We've been working on developing some products based on the container supply chain. And so we're not amazing speakers here, we're pretty amateurish. So you might find a few mistakes here and there, so please forgive us for that. So our topic is not going to be a lot of things which will go over your head, hopefully. So just like how you see on the title out here, Supercharge incident response across the container supply chain. So before we actually go into the crux of the talk, what's our agenda for the day? Very simple, just 4 things. We're going to be discussing about the container supply chain and how we can address different types of risks in the supply chain with a few examples, and how we bring out a solutioning, that is establishing a framework for navigating through vulnerabilities and threats. And we cover up with a small demo on how we brought about a solution on this. So predominantly, I was completely new to this whole field, and when I got to hear about this thing called the supply chain. For me, supply chain was about a ship bringing something from some part of the world to my house, and I see it delivered, and somebody asking me for a feedback on the delivery. So that's the supply chain I knew about until I came across this specific concept of container supply chain or software supply chain in essence. So what does supply chain mean here? Like as the diagram goes that you can see up here, anything that comes up to make a software product or an application becomes a part of a supply chain. For example, if you want to bring out a new application into the market tomorrow, we can't just code in some language and then just give it to anybody to use. So we have a lot of source code, we have a lot of dependencies, we have build tools, we have to store it somewhere, we have to finally go ahead and then deploy it in some place. For example, like your clusters or your self-managed containers or any place of that sort. So that whole cycle and all those components which are involved in that process makes up our software supply chain. And if you include containers there, so it becomes a container supply chain. So this is just a small example of a very small example that we have of maybe one small team in an organization working with 4 things. One is GitHub, which is our repo where we store our code, and we have Jenkins, which is our build tool, where we would actually supply the code, get an image as the result out of it, and then we have something like a JFrog Artifactory, for example here, which is a registry where we store all of these container images, and finally, whenever you want, you deploy it. And where you deploy it depends upon your requirement. It can be a cluster, which can be managed, unmanaged, or it can even also be normal containers. So quoting this example, why this whole talk of container supply chain and where is security coming into this aspect? So if you look it up on this slide, we can actually see that there are a lot of red lines across this whole container chain that you can see. So these are essentially factors or places where risks are introduced in your supply chain. Like as you have the code being built, to moving to becoming the application that you use, that whole chain involves a lot of processes, a lot of interaction among these components, and also has a lot of threats or risk factors involved. So if you focus on those vertical lines, you can actually see all of those risk factors. Now, there are a lot of frameworks which exist, like the SLSA as well as some of the CIS supply chain benchmarks available in order to address these issues. But more than all this, why is a SecOps person, or why does a SecOps person have to be very worried about these aspects? Simply because as the image gets built from the left to the right, you have a lot of components involved. So each of those components involved need to have security enforced on them, as well as the whole image build process as we move from point A to point B also needs to have security in there. So everything needs to have security in silos as well as when it is functional. So until and unless you have both these integrated, you cannot say your application that you built is secure. And only if you have these two can a SecOps person qualify that specific application or that build that you have to be compliant based on a few standards, or you qualify that image to actually be ready for production. So with this small understanding of why we actually have security into the container supply chain, we're just looking at some of the examples of where these risks or vulnerabilities can be found. Most importantly, just on these 4 pointers, where you can have vulnerable dependencies in your application code. So I'm sure that most of us developers, or whoever it is, we can't just code and then be happy saying that our code addresses it. You have a lot of dependencies involved in it. You have a lot of jar files coming. You have a whole load of other plugins, everything that comes into making your application whole. So how sure are you that all these sources from wherever you get all these are all safe? Next goes into using untrusted repos or registries. So the simplest example is we have the most trusted repo, which was Docker. So 2 days back, if anybody's been following, you can hear about the leaking vessels, which is a group of 4 vulnerabilities, which basically was targeting RunC as well as BuildKit. So those 2 are basically the backbones of our container image creation. Now, if there are no exploits of a massive scale, which is found till now, but these were things which actually led to something called as a container escape. That is, anybody or any hacker could just come in and then just get out of the container, move across your whole supply chain, and then get access to your host file system. Pretty dangerous in terms of, any organization which completely uses this. Same way, compromised CI/CD pipelines, like our Jenkins server itself throwing out vulnerabilities. And also some amount of your malicious code inside your container images. So these are some examples of where the risks and vulnerabilities come from. Moving on, this is just like a small example again, which is about the 2 NPM libraries, basically Faker and Color.js, commonly used among the developer community for testing, for development and testing. And what happened here is, one, the source code went missing. I mean, the developer himself removed all the source code and then brought about a new build. So anybody who updated could see that, okay, there is nothing, and every other packages which were dependent on it also started showing up issues. The other one, which is Color.js, was simpler. We had all the Node.js servers which was using that compromised. So these are small things which we might overlook in our development process, but that could result in disastrous results, which goes ahead. So that brings us to the point of the need to inspect certain things. What were the contents of the image when it was built, and the traceability of the image. That is, where did it come from, and who built that image, and the provenance of the image. That is, what was the security of the components while the image was being built. So now moving on to the solutioning part. So now we've been discussing for long about, okay, we have container supply chain, we have components involved, we know that these kind of threats and issues and stuff come, but you need to find a solution to it, right? So for step 1 of solutioning, the easiest thing that anybody can think about is to get telemetry across all those components involved in your supply chain. So my supply chain basically just includes these 4 components, and there are 2 segments of data that I would collect as part of telemetry. One would be the specific configurations associated with each of these components, like GitHub and Jenkins, and also the activity, the input, the output, what is happening in between, who is the person who's pushing certain amounts of code into the repo, and when did it come. All these are quite essential telemetry that we always need. Once we have the telemetry, the next thing is to ask a few questions on the data that we have gathered. So, and specifically we are considering an image here, right? So you need to check that, okay, you have an image, and one image can have one base layer followed by any number of layers. So, and any layer in that can also exhibit vulnerabilities. We need to be able to capture layer by layer information of all the vulnerabilities. Image provenance, again, coming to the fact that while the image is being built, what was the status of those software components which were involved, and throughout the pipeline could we actually find out some issues. And traceability comes again back to who built the image, when was it built, how did it make it here, and image signing and verification. So here the images will have to be signed by trusted authorities, and only then we make use of them in our pipelines. So this was just step 2. So it's step 3 and followed by the demo. Raghav is just going to complete the whole life cycle that we were discussing.
Thank you. So far we've discussed about the whole supply chain, what it is and what are some important use cases around it. So let's talk about the step 3, which is apply guardrails and controls in your supply chain, right? So what is happening here is that at each node or each step of your supply chain, GitHub, Jenkins, JFrog, and finally deployment, there is some telemetry that is being collected, as Sneha already spoke about, right? So what do we do with that telemetry? How do we tell someone that something is wrong with some configuration on your GitHub? That's where the OPA policies come into picture. So there are some CIS benchmarks that for a solution we have converted into OPA policy, and we have also written our own OPA policies to actually that we run against the telemetry that we have gathered. And to sum it up, we show it in a UI where whoever is using this will get to know at each step what was wrong, why did this bug happen. They'll get the root cause of that. Okay, this is the vulnerability coming from the code itself, not somewhere else, right? So let's go to the demo now. Yes. Sure. So what you see on the screen is right now the leftmost part of your supply chain, which is your code coming together, right? So this is a commit which is a part of a merged PR, right? A PR has a lot of commits, can have multiple commits, and this is one of those commits. In this commit, what you see here is that there is a switch case or switch statement with a duplicate case. So there are two cases, both are the same. The condition for both the cases is same. So this can actually end up in a bug in your environment, right? But somehow this got committed and got merged also. Which means that it is approved by someone, right? So this is the leftmost part of it, of your supply chain. Now comes the PR. This is one PR which is approved by one single person. It has 3 commits, if you can see on the screen, right? It has 3 commits, and this is already merged. Why I am emphasizing on merged is because when a branch or a child branch goes into a parent branch, there is a CI pipeline that gets triggered. What this CI pipeline will do is basically it will create a build out of your repository. In this case, GitHub repository. When that build happens, it's gonna finally deploy that build or store that build on some registry, artifact in our case, and finally that gets deployed somewhere. That particular image can get deployed anywhere, a Kubernetes cluster or somewhere in the AWS, right? So this PR is already merged, which means there is a build that exists for this repository. Yeah, so moving further to the actual image provenance page. So on this page, what I want to show you is that the build of that image that of that repository is already there. You can see that okay, this is the whole thing. Above here, it tells you that okay, there were total around 173 packages that got into that image, right? This is the associated host this is the container that it was deployed to, right? And on the bottom, yeah, here you see the whole history of that image, where it started from. These are the commits on your left or PRs. Then the commit goes into a PR, which becomes a part of the repository when you merge it, and then it goes to the Jenkins pipeline, CI pipeline, and eventually gets stored in the Jenkins pipeline will give you an image, which will get stored in your artifact, right? So I'm going to discuss on each of these nodes, and we're going to get into briefly discuss about the CIS checks that happen on each stage. So as you can see, this is the commit part. So you are able to find out what all commits went into this PR, right? You can see that, okay, there was only one guy who reviewed this, or one person who reviewed this, and there are 2 violations also. We'll discuss about the violations also here. Yeah, so one guy approved it, and now to the violations. Right, so you can see that two of the violations have actually failed. One of them is the CIS benchmark, the other one is provided by us. Right, we'll talk about one of these. Yeah. So, why has this one failed? This says that there's a crossover there, which means that this is failed. So this benchmark or this basically policy wants to ensure that each of the PR has been reviewed by multiple authenticated users. Right now we could see that okay, only there's one review and it got approved and we merged it. But the policy says that it should be more than one, multiple users. So that is why this particular policy has failed. Right. So this was the commit part, the leftmost part. Now moving right in the supply chain. Yeah. So this is the PR that it was a part of, and after the PR we get into the repository. So there is telemetry that we collect for activities, which was the PR and the code, right? Now there is telemetry that we collect for configuration also. So if GitHub repository has been configured, let's say with some code QL scanning, and you can see here that it was able to detect that there was a duplicate switch switch statement, right? So it is giving you that alert that this PR had a duplicate switch statement. And again, we run some policies on this configuration data also. So you can see like 13 of them have failed. Again, there is a CIS benchmark which is CIS 1.3.4. It says that this has failed because MFA was not enabled for that user who committed code. So that is also part of a benchmark. Now moving further right comes the build, which is the Jenkins in this case. Yeah, so this is the Jenkins part. Same scenario here, we run configuration or CIS checks for Jenkins configuration also. The first one has passed in this case because the CIS benchmark wants to ensure that all the steps of the pipeline are written as code, nothing is manual there. Now moving on to the final part of the supply chain for this particular image, which is the artifactory, right? So you can see that there is some information here collected, which is anonymous user status and checksum policy type. These are configurations of your artifactory. It means that a user can pretend to be anonymous on your artifactory first of all, and the checksum policy for the repository in your artifactory or in your registry is client checksum, right? So why that was important was because we are running checks on that also. So the first one, if you see here, it says disable anonymous access to artifacts. What this means is that you have enabled anonymous access to your artifacts, which can be dangerous. You will not be able to find who did what, because the log would just say that anonymous user did this and did that, right? And the last one, that is 4.3.1. This is where ensuring that all the images that the client is providing, in our case Jenkins, is providing are authenticated. They have a checksum attached to them which the client should provide, and Artifactory or a registry should validate that once the artifact has been uploaded. So this is again a CIS benchmark. So with the client checksum policy, it means that client has to provide a checksum and server will validate that. Okay. So that is around the supply chain for this particular image. I'll show you another one which got eventually deployed also. Yeah, so as you can see on this picture, there were two PRs that went into your branch, and that became a part of your repository. Eventually there was a build for it. It also got deployed on your registry and also got deployed on a private Kubernetes cluster. Yeah, so that's all for the demo. Sneha, over to you now.
So if you actually notice, what we've been trying to do is we've not left any component to have any piece with itself. So every single component we included in our supply chain, we made sure that we were hardening on the security aspects, and towards the end where we have our images being deployed on our clusters too, we can have policies custom made and written, giving it more admission control capabilities. Okay, so if we actually give you a representation like this to anybody in your organization, where you have both DevOps, SecOps, people sit around to fight around saying that this is okay, we can actually have this go in production. Giving this picture gives more clarity to everybody to figure out whether that specific build or that image needs to make it to production. If not, the decision becomes easier to say that, okay, these are not compliant by this much percentage. So why take it and then compromise everybody and everything around? So this kind of a solutioning actually helps harden security and also helps make better DevSecOps decisions for all organizations. So that's basically what we wanted to cover as part of our talk today. And these are just the 4 steps again, which we have, and all the different kinds of tools and checks which we had throughout the process. So by way of which, what we try doing is we try to ensure integrity, traceability, and provenance across the software supply chain, and also at the level where our Kubernetes clusters were involved. So that's like a solution that we brought about, considering the issues around supply chain. Thank you.
So what you showed us could be actually done with, I think, any existing tool. Like if I integrate GitHub Action with Sonar, that would help me do the same thing. So like, what's the USP of Uptycs that one would go towards Uptycs and not any other existing one?
So yeah, yes, there are ways to achieve it in the market. Yes, I think what we are bringing to the table is basically the telemetry, getting to the same consolidated telemetry to tell you the whole end-to-end life cycle of your image. With one screen, you would be able to basically find out what went wrong, where it went wrong, and maybe put more emphasis as a user or as someone who runs an organization to actually consider, focusing on the left part of it, the code, where things actually get into play. So, yeah, thank you. Anything else?